Rahim. Today our lab is to implement different functions like encoder, multiplexer, decoder and demultiplexer using universal gates. So the objectives of our lab is learning how to implement a circuit using universal gates on breadboard and on Proteus, also implement and comparing the results of encoders and multiplexers using the universal gates. So basically in this lab we are going to implement the muxes, encoder, decoder and demultiplexer using not ICs but through basic gates, and then we have to compare the results of encoders, multiplexers and decoders and demultiplexers, and we have to see what is the relationship between their inputs and outputs and what is the relationship between their working. So basically it is the mux. We have the logic diagram of our mux in which we have 4 inputs and 2 selection lines. So on the basis of selection lines we obtain the output, and after that we have a demultiplexer. Demultiplexer is basically the opposite of multiplexer, in which we have only one input and based on the selection line we get the output. Or after that we have the logic diagrams of encoder and decoder, and here is the truth table of 2x4 decoder. You can see that here is the 2x4 decoder, so we have 2 inputs and 4 outputs, and on the basis of inputs we get the output. When our inputs are 0 0, so we get the output at the output 1 terminal, and when our inputs are 0 1, so we get the output at our output 2 terminal. So this is the truth table of our 2x4 decoder, and after it we have the 4x2 encoder in which we have 4 inputs and only 2 outputs, and basis on the input we get the output. After we have the truth table of demux and mux. Now by using these multiplexers, demux, encoder and decoders truth table, we have to implement the circuit of these on Proteus, and after Proteus we have to implement these on the Verilog SDL. So let's move to the Proteus. Now here on the screen you see that I have implemented the circuit of a 4x2 decoder and a demux, 2x4 demux. On the left hand side you can see the circuit of a decoder in which we have the 2 inputs, input 1 and input 2, and here is the 1 is the enable input, and we have 4 outputs D0, D1, D2 and D3. Enable is always 1 because when enable is 0 all our outputs become 0, so enable is always 1. And on the basis of input, when the inputs are 0 0 we get the D0 1 and all other will be 0, and when we get the input 0 1, then our D1 is 1 and all other are 0, and similarly when we 0 1 and D2 is 1 and all other are 0, and when both are 1 1 our inputs, then we get the output D3 1. It is the function of a decoder. After it we have the demux in which we have only one input and 2 selection lines, and basis on the selection line we get our input at the output terminal. So you can see that this is the relation between decoder and demux. In decoder we have 2 inputs and 1 enable line, but in the demux we have single input and 2 selection lines, so all other circuit remains the same. The only difference is the inputs. In decoder we have 2 inputs, and in demux we have only single input, and in decoder we have 1 enable, and in demux we have 2 selection lines. So this is the only difference between decoder and demux, and all the remain function remains the same. So when we run this circuit, now you see that whenever in decoder when we have the inputs 1 1 and enable is 1, so we get the output D3 1 and all other are 0 0. And similarly in this demux when we have the selection lines 1 1 and input is 1, we get our input at Y3 terminal. And now when we change the input, I here get the input 1 0 0 1 inputs. So in decoder we get our output at the D1 terminal, and in demux when I am going to change this, when I get the input 1 0, so we get the output at Y2 terminal. So this is our decoder and demux. You can see that when all the inputs are 0 0 in decoder, we get our output at the D0 terminal. And similarly in demux, when our selection lines are 0 0, we get our output at the Y0 terminal. So this is the functionality of a decoder and demux. Now we will see what is the functionality of a encoder and multiplexer. Now you can see the circuit of a 4 to 2 encoder and 4 to 1 mux. On the left hand side I have implemented the circuit of a encoder, and on the right hand side I implement the circuit of a mux. So encoder, you see that we have 4 inputs and 2 outputs, and we encode our inputs into using only 2-bit outputs. And on the right hand side you see that I have implemented the circuit of a 4 to 1 mux, in which we have only 4 inputs and a single output. And on the basis of selection lines, we select which input we have to obtain at the output terminal. So when I run this circuit, now you see that in the encoder. Now when I run this circuit, you see that in encoder, when we have the inputs 0 0 1 0, we get the output 1 0. So basically we have turned this 4-bit input into only a 2-bit output. 0 0 1 0 and 1 0 means the same. And on the mux, you see that when we have the input 0 0 1 and we have the selection 1 1, so basically we get our I3 input at the output terminal. Now when I change the selection lines, when the selection line says 1 0, so we get our I2 input at the output. So you see that when our I2 is 0, we get the output 0, and when our I2 is 1, we get the output 1. And now when I am going to change our encoder inputs, you see that now when I give 1 at the I0, we get the output 0 0. Now when I am going to give I1 input 1, so we get the output over 0 1. And now similarly when I am going to change here inputs on the mux, and I am going to change the selection lines, when I get the selection line 0 1, we get our I1 input at the output, and I1 is 0, so we get the output 0. And when I get both selection lines 0 0, so we get our I0 input at the output, which is 1. So basically this is our 4 to 2 encoder and 4 to 1 mux. Now in the very log, you see that I have implemented the code of a decoder and a demux. In decoder we have the following inputs: input 1, input 2 and enable, and we have the 4 outputs D0, D1, D2 and D3, because it says 2 to 4 decoder, so we have 2 inputs and 4 outputs. And after that we have the assign statement for our outputs, which are D0, D1, D2 and D3, and here it is the following code for a 4 to 2 decoder. After this I have implemented the code of a demux, which is 1 to 4 demux, in which we have only 1 input and 2 selection lines, which is S1 and S2, and after that I have applied the case statement, and on the basis of cases we get our output. So after this I am to start compilation. So when I start compile, it takes some time, so let's wait. Compilation of our program is completed. We have to make the waveform of our input and output, so here I am going to make that. I am going to insert all the nodes here. So we have the following inputs and outputs. We have the following inputs: enable, input 1, input 2, input 3 and similarly so on. Now I am going to set the periods of these. you see that I have given the time period to all the waveforms. Now I simulate this. Now you see that our waveforms are generated. The output D0, D1, D2 and D3 are for the decoder, and the output Y0, Y1, Y2 and Y3 are for the demux. Now you see that now for the decoder 1 we have the enable 1 and we have the input 0 0, so we get our output at the D0. And when we have the enable always 1 and when we have the input 0 1, we get the output over at D1 terminal, and when the inputs are 1 0, we get our output at the D2 terminal, and similarly when the inputs are 1 1, we get our output at the D3 terminal. So these waveforms are for the decoder. And now for the mux, when we see there, when we have the selection lines here, S1 and S2 are the selection lines. When we have the selection line 0 0 and input 2 is 1, so our output Y2 is 1. And similarly when we have the selection lines 0 1 and then Y1 terminal will give the output, and when we have the selection line 1 0, then Y2 terminal will give the output, and similarly so on. So by using these waveforms you can very easily verify the truth table of a decoder and demux. So this is enough for today's lab. Thank you.